Additional problems now. You're a good Devin.
So you didn't put mic.
Sorry, ma'am. Right. Good morning, everyone.
Good morning, sir.
Right. So let's get started with the. Let's do some good problems now. All right. So, for instance, I've got this is a horizontal table. All right. I'm looking from above. I've got a rod along which there's a bead which is connected to a spring. And spring is one end of the string is hinged here. Is looking from above. This angle is 37 degrees. This is D. Or this is X naught. X naught is the natural length of the spring. All right. It is stretched till here and left. All right. What is required is I have to find the speed of this bead when it reaches this equilibrium position. ఏమవుతుంది ఇక్కడ I stretch the string like this. It's from horizontal. You're looking from above. Horizontal plane లో ఉంది. So it's stretch చేసినప్పుడు spring will get stretched. It will pull the bead here. Force will have a component along this, because of which it will accelerate. It will accelerate, gain speed. ఇక్కడ నుంచి ఓవర్షూట్ అయ్యి మళ్ళీ రిటార్డ్ అయ్యి మళ్ళీ ఇక్కడ ఆగుతుంది. సో సిమెట్రికలీ ఆసిలేట్. ఇక్కడ నుంచి ఇక్కడ ఆసిలేట్ అవుతుంది పార్టికల్. All right, that we can talk in terms of forces. We can solve this problem in terms of forces. But I told you, whenever time or acceleration is not asked, we can go for work energy method. Whenever only speed is asked, go for work energy method. Required to find the speed over here, V naught. It is released from rest here. So let's conserve energy. What is the initial total energy? Kinetic energy is 0. Potential energy is half k delta x square. String constant is k. Half k delta x square is equal to, when the spring comes over here, it's the natural length I said. X naught is the natural length. So potential energy is 0 and kinetic energy is half m V naught square. Right. Now all I have to do is plug in delta x. How will I plug delta x? Delta x would be this length minus natural length. So how much is this length now? ఈ length ఎంత ఉంటుంది? If this angle is 37 degrees, what is the hypotenuse? If base is x naught, what is the hypotenuse if angle is 37 degrees? X naught by L is cos 37. చెప్పండి.
Sin 37 into V naught.
సారీ,
సో సైన్ లో తీసుకుంటే ఒకవేళ
వాట్ విఘ్నేష్? సారీ,
మీరు కాన్స్టెంట్ అడిగారు కదా సార్, అప్పుడు కాస్ 37 ఇంటూ ఎక్స్ అవుతుంది కదా.
ఎక్స్ బై కాస్ 37 అవుతుంది కదా. ఇది ఎల్ అనుకుంటే ఎక్స్ నాట్ బై ఎల్ is cos 37, which is 4 by 5. So L is equal to 5x naught by 4. నాకు లెంత్ వచ్చింది. Is it okay? Is this okay? 5x naught by 4 is okay?
Yes, sir.
Now length వచ్చింది. I want the extension in the spring. So this length minus natural length will give me extension in the spring, which is x naught by 4. So half gets cancelled out. K x naught by 4 whole square is equal to mb square. So v naught is equal to root k by m into x naught by 4. So I get the speed like this. Is it okay? All I did was physics of the problem ended here. Energy conservation. Initial total energy is equal to final total energy. There is no dissipation of energy anywhere, no friction, nothing. And it's in the horizontal plane. So half k x delta x square is equal to half mb square. Initial total energy should be equal to final total energy because energy is conserved, energy is captured. Initial kinetic energy is 0. Initial potential energy is half k extension in the spring square is equal to final potential energy is 0 because it's a natural length. X naught is a natural length, I said. Plus kinetic energy is half mv square required to find v. All right, there ends the problem actually. After that, it's just a simplification. So problem akkada end అయిపోయింది. All we had to do was plug in delta x and find out v naught. Delta x is from the geometry. All right, now let us say this is not in the horizontal plane but in vertical plane. అప్పుడు ఏమవుతుంది? అప్పుడు ఎలా చేస్తాను? Whenever you have gravity involved, take a reference level as take some level as reference level. For instance, let's take this level as reference level. 0 level తీసుకుందాము. ఇప్పుడు ఏమవుతుంది? Drop in. What is the initial total energy? mg into h. Let's say this is h plus half k delta x square is equal to half m v naught square. Now all I have to plug is x and delta h. Delta x and h. ఇప్పుడు h ఎంత చెప్పగలుగుతారా? If the angle is 37 degrees, this is x naught. What is h? What is h in terms of x naught? You can use tan 37. H by x naught is tan 37. Tan 37 is 3 by 4. You get h from there. Can you tell what is h? Gayatri, Ashrita, Shashank, Bharat. What is h?
Tan 37 3 by 4.
Yeah, tan 37 is 3 by 4.
Then x naught is equal to 4h by 3.
Right. No, 3h by 4. See? H by x naught is equal to 3 by 4. So h is equal to, yeah, x naught is 4h by 3. You're right. So, but I want h in terms of x naught. So 3x naught by 4. So mg times of 3x naught by 4 plus half k delta x. Delta x into x naught by 4 whole square is equal to half m v naught square. All you have to do is find V naught from here. Multiply this with 2. Divide by mass. Take the square root. That's it. Alright, here ended the physics of the problem. Ikkada energy equation, class and that was the end of the problem. After this, I just simplified it further. I took m on this side, 2 on this side, multiplied, cross multiplied, and took the square root of the RHS or LHS. Okay. Okay, now let's go for another problem. Is there any doubt over here?
No, sir.
Okay. Shashank, today is your first class.
Yes, sir.
All right. Which college are you from?
COE Bellampalli, sir.
Acha. Oh, COE. But then you have holidays, that's why you're able to read it.
Yes, sir.
All right. Again, after holidays, you'll go back.
Yes, sir. On 15th.
15th. All right. All right. All right. Okay. I've got a block. There's a spring here at natural length, released like this. Block of mass m, spring constant k, and the block is released from height h from the spring, natural length of the spring. All right. I have to find out. Let's see what's happening. Before we understand what to find out, let's see what's happening. As the release is from here, force terms it will accelerate because of mg. It will accelerate. It will accelerate. It will gain some velocity here. Once it touches this plate, string gets compressed. It will go to the maximum compression state where the velocity becomes 0. I have to find out this maximum compression in the spring. All right. Required to find the maximum compression in the spring. But why do you get the maximum compression there? At compress auto, it'll cross the equilibrium position, overshoot, and reach the bottommost position with the speed 0. It will stop at that position. So that's a very key point over here. That we will use the speed 0 over there in the equation. So we need to find the maximum compression in the spring. So let's see how do we find out. And there are other questions as well, but let's find out maximum compression in the spring. Before that, let us also find out the equilibrium position of the spring. Spring constant is k, mass is m. At equilibrium position, this is my natural length position. At equilibrium position, x equilibrium is equal to mg by k. Why is it mg by k? Force kx is upwards. X equilibrium, mass as m, force mg is downwards. So gravitational force is downwards. So this is being counterbalanced by this in equilibrium position. So I'll write kx equilibrium is equal to mg. So x equilibrium is mg by k. All right. So at equilibrium, what is the acceleration? 0, because the forces are 0, net force is 0. That's the definition of equilibrium position. All right. And whenever we talk of equilibrium position, we'll talk of whether it's stable, unstable, or neutral. Stable or stable equilibrium position, or it's unstable or neutral. So, but whenever you have a spring, that will either be a stable or unstable. All right. But in this configuration, it will turn out to be stable. That we'll look into it why it's stable. But let's find out the maximum compression first. Maximum compression ఎలా కనుక్కుంటాము? Either it's using forces we can do, but I told you whenever time or acceleration is not asked, only velocity is asked, we can go for energy method. So initial energy మళ్ళీ reference తీసుకుంటాను. I'll take the reference to be the bottommost point of the compression as zero reference level. All right. So my initial energy is mgh plus x, right? Because h is from natural length, x is the compression. So total height is mgh plus x. And final energy is spring energy is of course there, half k x square plus what is the kinetic energy of the bottommost position when the particle stops momentarily? What is the kinetic energy at that position? Yeah, Vignesh, you're saying something?
So is it 0?
Yeah, it is zero because it stops momentarily. So kinetic energy over there is zero. So all I'll have is required to find x from here. Anything else is missing? Yeah, that's it. So kx square minus 2mgx minus 2mgh equal to 0. So root of this equation is my solution. So physics ended here. Physics of the problem ended here. Rest is now mathematics. Now in that what we do, you've got a quadratic. How do you solve a quadratic? Either factorize it. If not factorizable, directly go for the formula. Minus of b plus or minus b square minus 4ac by 2a. So minus of b is 2mgh, 2mg plus or minus root of 4mg square plus 8kmg by 2k. So 2 gets cancelled out. I take 4 common, 4 out of the root, it becomes 2. 2mg plus or minus 2 root that by 2k, 2 gets cancelled out. And this is your answer. Look at this. Negative my x is the distance from the natural length. Alright, it's a distance from the natural length. So I discard the negative root, pick up the positive root. And that's my answer. Alright. But now let's say I have to find out the speed at equilibrium position. I have to find out the speed at equilibrium position. So how do I do that? అప్పుడు ఎలా చేస్తానంటే already energy conservation equation again for the same thing. Energy conservation equation for at equilibrium రాస్తాను. So I'll have mg into x h plus x prime, that's equilibrium position x e is equal to half k xe square plus half m ve square. Now xe enta telusu manaki. Xe is how much? Mg by k. Just substitute this xe over here, you'll get the answer. I mean, do you understand what I'm doing? I'm just focusing on the physics of the problem, students. The simplification everyone cheyochu kada. There's no big deal in it. I've got this equation from energy conservation equation is ochindi, but this is at extreme position. That's why my kinetic energy is 0. But if it is not at extreme position, my kinetic energy will be some half mv square. That kinetic energy is being added now. So initial energy is equal to total final energy. Initial total energy is kinetic energy is 0. My gravitational potential energy is mg into h plus xc is equal to half k xe square, because at equilibrium also the string is compressed. All right. String natural length లేదు, natural length కంటే కొంచెం కంప్రెస్ అయింది అంటే స్ప్రింగ్ పొటెన్షియల్ ఎనర్జీ స్టోర్ అయింది. దట్ ప్లస్ కైనెటిక్ ఎనర్జీ ద టోటల్ ఎనర్జీ ఫైనల్ ఎనర్జీ. But again, you will have gravitational potential energy as well. Plus mg into okay, fine. You will not have gravitational potential energy because I'm taking that as a reference level. Okay, I'm taking that level as reference level. అందుకే mg h plus xc రాశారు. All right, that's clear. That's why you not have a gravitational potential energy term over here. R level reference level తీసుకున్నాం. Whenever you have gravitational potential energy, you will have to take a reference level. In fact, any potential energy term, you will have to take a reference level. Spring law, natural length is a reference level. All right, that is 0. Reference level and which what you're marking as 0. What's your datum is 0. So gravitational potential energy 0. I have taken this level to be the reference level. A level, equilibrium position level, wherever I require the speed. So that is mg x plus h plus xc is total gravitational potential energy initial. Kinetic energy is 0. Final is gravitational potential energy is 0 because that is the reference level. Plus spring potential energy plus kinetic energy. All right, all you have to plug is this one. So let's do it. Mg by k. That's it. You just plug in. Shall I do it? Or will you simplify and tell me what is VE? Or you take a minute and simplify this and tell me what is VE. We can go for the other problem. Instead of solving this one further. Instead of simplifying this one, we can go for another problem. Can you tell me what is the simplified VE now? Substitute XE as mg by k. Because at mg by k, particle is in equilibrium. At that equilibrium position, I'm finding out speed. So at equilibrium, we'll have maximum speed. అక్కడ వరకు accelerate అవుతుంది particle, దాని తర్వాత retard అవుతుంది. So acceleration is taking a turn. Acceleration reverse అవుతుంది. Acceleration కింద ఉంది, మరి acceleration పైకి ఉంటుంది. So acceleration కింద ఉన్న వరకు particle accelerate అయింది, speed up అయింది. Then it will start retarding. Acceleration is upward, net force is upward. So maximum speed will be at VE, at equilibrium position. That speed we are finding out. All right, if you were to say find the maximum speed, same equation. Find the speed at equilibrium position, same equation. Because at maximum at equilibrium position itself, we'll have maximum speed. All right, I'll go for the next one. Students, this week we'll have an extra class. All right, and only for MPC students. This block is mass m, this is also m. All right. Released from rest when it's at natural length. Natural length ఉన్నప్పుడు I release from rest. I have to find out the maximum extension in the spring. That's the question. Again, maximum extension అడుగుతున్నాడు. We can do it using force method also, but whenever time or acceleration is not asked, better go for energy method. That will be a lengthier method. You try once. Force method లో ఎలా చేస్తారో try చేయండి. That will be a very lengthy method, but energy method is one step. Okay, so what happens over here? The moment I release it, this will go down by x. This will go towards right by x. So spring will get extended by x. Accelerate అవుతుంది. Equilibrium reach అవుతుంది. Equilibrium తర్వాత retard అవుతుంది. Will stop at some point. That position is what I have to find out. At what x will it stop? All right, then we'll also find out what's the maximum speed of the particle. Again, the moment I say maximum speed, it is acquired. It is acquired at equilibrium position. So first we'll find out the maximum extension in the spring, then we'll go for maximum speed. So how do we do this? ఎలా చేద్దాము? Energy conservation. I'll take this as reference level. ఏది? The maximum extension is as my reference level. Drop in potential energy ఎంత అవుతుంది? mgx. That is equal to gain in spring potential energy and kinetic energy. Spring potential energy ఎంత అవుతుంది? Half kx
Half
square.
mu x square. Right side
Yeah.
of k.
Yeah. And then what is kinetic energy over there at the maximum extension? Particle stops momentarily. So kinetic energy is 0.
0.
Right. So one x gets cancelled out. I'll have x is equal to 2 mg by k.
Yes, sir.
Can you tell me what is the equilibrium position? Equilibrium position of what is the extension? At equilibrium position, let that be x naught. Mg should be equal to kx naught. Mg should be equal to kx naught. Kx naught should be equal to mg. So x naught is equal to mg by k. Shouldn't it? This is double of that. This is mg by 2 mg by k. This is mg by k. So equilibrium is mg by k. Momentarily stops at 2 mg by k. It's traveling double the distance in stopping. That means it is oscillating symmetrically about mg by k. All right, we'll plot a graph also for this, but later. Let's just understand how to write equations out, how to write energy conservation equations for these problems. All right, graphical analysis and all we have to do, but we'll do it. For the previous problem also, we have to draw the graph of f versus x. All right, you try to draw for this graph, for this particle, for this problem. దీనికి f versus x ప్లాట్ చేయండి. దీన్ని కూడా ప్లాట్ చేయాలి. And we have to spot the similarities between problems. ఈ ప్రాబ్లం ఆ ప్రాబ్లం similarity ఏంటి, graphical similarity ఏంటి. So situations, how is the situation similar? How is this problem an old problem? All right, or if a new problem is given to us, how can we fit that as a fit that into a new old problem itself? Our patterns recognize చేయాలంటే we'll have to do some analysis, graphical analysis చేస్తే all those patterns will become clear. Anyway, now let's find out the maximum speed of the particle. Maximum speed అయినప్పుడు ఏమవుతుంది? Let's say that is coming down by mgx by x. Maximum speed ఎప్పుడు అవుతుంది? At x naught, at mg by k. So I'll write mg into x naught initial energy is in the that is being converted to final ఏమేముంది like energy is captured, there is no loss of energy. Initial energy ఇంత ఉంది, final energy లో ఏమేమి ఉన్నాయి, half k x naught square spring potential energy plus half m v naught square into 2. Masses are same, velocities are same. I'll write 2 into half mv square. It's actually half m1 v1 square plus m2 v2 square actually, because masses and velocities are same. All you have to do is plug x naught is equal to mg by k in this one. You'll get the maximum speed required. Okay, can you just plug that in and tell me what is the maximum speed? I'll further simplify. So I'll have 2mv square. This goes off. So 2mv square is equal to 2mg x naught minus kx naught square. V naught square is equal to 2m gets cancelled out. I'll have gx naught minus k by 2m x naught square under root. Alright, now just plug x naught is equal to mg by k. Alright, so what do you get when it is mg by k? X naught is mg by k. Can you further simplify this and tell me what is at mg by k ఉన్నప్పుడు x ఏముంటుంది, సారీ v ఎంత ఉంటుంది? Students, what is happening here is, let us think in terms of ఈ గ్రావిటేషన్ పొటెన్షియల్ డ్రాప్ అవుతుంది. ఆ డ్రాప్ అయ్యే ఎనర్జీ ఎక్కడ వెళ్తుంది? దట్స్ గోయింగ్ ఇన్ టర్మ్స్ ఆఫ్, ఈ స్ప్రింగ్ లేకుంటే దట్ విల్ గో ఇన్ టర్మ్స్ ఆఫ్ స్పీడ్ ఎక్వైర్ అవుతుంది. సో దిస్ both the particles will accelerate, but gain speed, gain kinetic energy. But spring కూడా ఉంది కాబట్టి this drop in potential energy mg into x naught is being captured by, because total energy is conserved, this energy lost is gained by spring energy and kinetic energy. Kinetic energy is being split between two particles. ఇది ఒకవేళ లేదంటే then things will be different. Maximum extension అంతే ఉంటుంది, but maximum speed will not be the same. Alright, because one term is missing now. దీనికి kinetic energy ఉండదు, but when you have mass for this as well, kinetic energy is being split into this and this. So this total energy drop, total gravitational potential drop is gained by spring and kinetic energy, spring potential energy and kinetic energy. That's what we are writing ultimately. Mg into x naught is half kx square plus half mv square plus half mv square. And why do I say the speed is maximum at the equilibrium position? Because at equilibrium position, net force is 0. Till equilibrium position, my particle accelerates. Beyond equilibrium position, particle retards. So my particle is oscillating between these two actually. Alright, చూడండి, for the particle to be pushed towards right, ఈ region లో ఉన్నా కూడా, note this point, ఈ region లో ఉన్నా కూడా my spring is pulling. But because you have got mg, it's going towards right. I mean, because this downward force you have got pushing, supporting, that's going towards right. So it is oscillating about this equilibrium position. It's not oscillating about natural length position of the spring. It is oscillating about this position. So for today, what you do is, I've got vertical hanging block. with a spring. I release it from natural length. I have to find the maximum extension in the spring. Try to find this out. All right. It will reach equilibrium, accelerate till there. After that, it will retard. You will see that it will symmetrically oscillate about equilibrium position. How will you know that symmetrically oscillate అవుతుందని? Equilibrium position mg by k ఉంటే maximum extension 2 mg by k వస్తుంది మనకి. When you find out maximum extension, how will you find out? You will apply the similar equation there. But instead of having two terms of kinetic energy here, you'll have only one term of kinetic energy here. Those are in one block. All right. Any doubts over here? All right. If you have got no doubts, we'll end the session here.
So,
Yeah.
x naught mg by mu k ఉన్నప్పుడు ఆన్సర్ అండర్ రూట్ mg స్క్వేర్ బై 2k నా?
Yes. Under root mg square by 2 mg square by 2k.
ఓకే సార్.
That's right. You're right. So that's the maximum speed we got. Right. అదే నాకు వేరే ఇన్స్టెంట్ లో స్పీడ్ కావాలంటే అప్పుడు ఏం చేస్తాను? ఇన్స్టెడ్ ఆఫ్ equilibrium extension, I have some other extension there. X తీసుకుంటాను. I'll plug in X, I'll get V. Or if V is given, I'll plug in V, I'll get X. I can ask you at what position is the speed this one, given speed. 2 meters per second, 2.3 meters per second, anything. Given speed in the question. అప్పుడు ఈ ఈక్వేషన్ సేమ్ రాస్తాను, బట్ రిక్వైర్డ్ పారామీటర్ రిక్వైర్డ్ ఏది సబ్జెక్ట్ చేసుకోవాలి విల్ బి డిఫరెంట్. ఇప్పుడు V నాట్ కావాలి, X ఇచ్చారు. అదే X ఇచ్చారు, X కావాలి, V నాట్ ఇచ్చారంటే యూ కెన్ యూజ్ ద సేమ్ ఈక్వేషన్. So physics of the problem same, maths of the problem will vary a bit. All right. And mostly advanced questions law, you will have symbolic questions itself. You will not have, if at all you have numbers, numbers will be such that they'll be simplifying calculation. So you will not require, you don't have to be very fast in calculations. You will have to be very fast in ideas. All right. Symbolically, ఎలా manipulate చేయాలి అది రావాలి. All right. Any other doubts you have got? All right, then we'll stop here. Bye, everyone. See you in the evening. Have a nice day, everyone. Bye.